Very good morning. Welcome back to the session. This is Raghavendra, Associate Professor, Information Technology, Aeronautical Engineering College, Hyderabad. Today we will discuss about data link layer. We know data link layer is a second layer in OSI reference model. So in this particular layer, we are going to discuss about what is OSI, what is the data link layer, what are the functionalities of data link layer, what are the merits, what are the uses, what is the role of this particular layer for transferring the data from source to destination. Let's see the session. Data link layer is the second layer in OSI reference model, and it frames bits into bytes and bytes into frames. Why? Because bits into bytes and bytes into frames. Why? Because we know well in the physical layer what we have discussed. So the data will be represented in the form of bits. Okay. Now this is the second layer. That means the physical layer is connected to data link layer. Now, how that in the data link layer, what we have discussed in the picture, the data can be represented in the form of frames. Okay, so in between, okay, so how it is going to be grouping means, so here the bits are into represented into bytes, and again bytes into just grouping into frames, right? So we know that bit is nothing but only 1 or 0, isn't it? Byte means 8 bits, isn't it? So some group of 8 bytes are going to be form as a frame, data frame, right? Physical addressing. So what is physical addressing? So physical addressing, adding header to the frame to define source and destination address. Okay. So in physical addressing means in data link layer, whenever the data is coming or receiving, okay, so then at the time what will happen? For example, sender want to send the data to receiver. Okay, so the data is coming from application layer to again next subsequent layers, it is going to be coming down, and when it reaches to the data link layer, it is going to adding header part to the data frame. Okay, so what this particular header contain means, so this header contain source and destination address. This particular header contain source and destination address. Okay, that means it is very simple that you can say that for example, when we are going to move to travel to the daily what we are going to do, so we are daily morning we are going to coming to the offices, isn't it? So we can wear the id cards. What id card is going to be displayed specified? So in the id card obviously we have some our home address will be available, and the destination address clearly specify their office logo, office address, everything will be there. So we can, whenever we can see that id, what we can easily identified, okay, so and so is a person, is the employee of so and so organization, so he is from so and so place, and he is traveling to this particular organization, isn't it? So likely, okay, in the header part, when data is coming, okay, immediately we just identify the header part, we're just going to add the source detail means that particular source system address, and whereas in destination address means, so to which system the particular data frame have to reach, okay, that address is going to be added here, clear, and it moves the frames from one node to the next. It moves frame from one node to the next until it reaches to the destination system. It is going to be moving from one node to another node. Remember, node, system, all the same terminologies, right? It provides flow control, error control, access control. What is flow control? What is error control? What is access control? Right? So this is very important. Please remember carefully. Please observe. Please hear it. So flow control means it just minimize the flow of data. That means, so sometimes what will happen in a network? So for example, you have a system, okay, and your friend is also having a system, okay, and this is source and this is destination. Okay, now the source system transmitting a mail to the destination system. Clear? The source system configuration is poor and destination system configuration is very high. So what will happen? And the source system network is also which is connected to one network now. Which is connected to one network, and destination system is connected to another network. Okay, so here this network might be little bit slow, and some other network which is connected, that may be the little bit faster than this one. So even though the whatever the data is going to be transferred, the data has to reach to the destination without any modification or any data loss, isn't it? So the same thing, it has to be maintained, because reliability is very important in the communication, isn't it? So this data link layer, it minimizes the flow based on the network capabilities, right? It is going to minimize the data flow. Even if it is very fast, it is going to be slow. If it will be very slow, it is just going to enhance the speed, right? So that is, it just moderate speed, it is going to be transmit the data bits to source to destination across the network. So that is the flow control. And error control. If any error occurred during the data transmission, so it is going to generate a report that error message. So if so and so data packet is lost due to this timeout or whatever the issues they are that data packet has faced, that is the reason. So the so and so data packet is not received by the recipient successfully. That message is going to be transferred to the sender system. So then what the sender system is going to do? Immediately, whichever the data packet is lost, that data packet is again it's going to be retransmitted through the internet or network, right? And access control. Okay, so we have a lot of set of access controls are there. So whether it is read access permission, write access permission, append, read, write. Okay, so like this we have some different access permissions are there, and these access permissions also given by this data link layer. Okay, and it will break up the input data into frames and transmit in sequentially. It just break up the input data into frames, because so it is so far we discuss when data is coming from bits to physical layer to data link layer, what will happen? So physical layer bits, okay, whereas here data is going to be converted into bytes and again frames. If the data is coming from the next upper layers, okay, data is coming from upper layer means obviously the data packet size will be more high than the frames. That means, so here in the next layer what will happen? So data can be represented in packets. Okay, now so when it reaches to the data link layer, it just break up the input data. That means packets are going to be divided here and make it into frames. Okay, and those frames are going to be transmitted sequentially, right? Flow control. Okay, so in data communication, flow control is the process of managing the rate of data transmission between two nodes to prevent a fast sender and overwhelming slow receiver. Okay, see, for example, in a lecture hall, if the professor is going to deliver lecture very fastly and student will take the data very slowly, then what will happen? Just data loss, isn't it? What if a professor will tell 10 points and students will able to grasp only 3 points? Okay, that is fast sender and slow receiver, right? With this, what will happen? The 7 points are going to be lost, isn't it? In the same way, in the network also, if the system or network is very high-end system, that means a very good high configuration system, then what will happen? That will be the particular system or that particular network will be very fast. if the same time other side the recipient also have a same good configured networks or systems are available, then there is no problem. So how can we say that everywhere have a same unique format, unique you can say that configured networks will be available. So somewhere we can say find that fast networks, and somewhere we can find that poor networks. Okay, so to avoid these sort of things, that is fast sender, slow receiver. Okay, otherwise slow sender, fast receiver also having the same ideal state is going to be happen. If slowly data is going to send, what will happen? So the network is going to be enter into the ideal state, isn't it? So that whenever the network will be in ideal state, the performance is going to be reduced, network performance, right? So that is the reason. So it just moderate the flow control. It provides a mechanism for the receiver to control the transmission speed, right? Just it is a provide a mechanism for receiver to control the transmission speed, so that the receiving mode is not overwhelmed with the data from transmitting mode. That means there is no issues will arise. It's just going to regulate the transmission speed according to the recipient network criteria, and it is going to transfer the data. With this, there is no issues will come, and there is no data loss is going to be occurred. So reliably the data is going to be transmitted from source to destination. And error control. Error control in data link layer is the process of detecting and correcting data frames that have been corrupted or lost during the transmission. For example, you just assume that data is lost during the transmission. So maybe whatever the reasons, that is, those are the secondary things we'll discuss. So only thing is we need to concentrate on error control. Okay. So if data loss occurs during the transmission, okay, so it has to identify where the data is going to lost. For example, so you are sending a 1,000 page document, okay, in somewhere, I mean in any some 96th page, in particularly in any some, so 20th line, okay, so one line is going to be missing here. Instead of sending this particular line, if again we are sending the 1,000 page document, is again putting a lot of burden into the network, isn't it? So this particular error control mechanism has to identify where exactly that error occurred, where exactly the data lost. These things need to identify and correct the data frames, and whatever the corrected frame or lost frame only need to retransmit. So in case of lost or corrected frames, the receiver does not receive the correct data frame, and sender is ignorant about the loss. And data link layer follows a technique to detect the transist errors and take necessary actions, which is retransmission of frames whenever error is detected or frame is lost. That means, so here it has to identify its necessary action has to take. Otherwise, what will happen if the receiver from the receiver end, it is not getting any response from the receiver? What the sender feels that okay, I send the 1,000 page document successfully, it's completely, it's over. Okay, but from the receiver side end, it has to come. So some particular frame is not received, particular frame is corrupted, this some data is lost, this particular data I didn't receive, that message has to received by the sender. Okay, so this error control mechanism is going to identify the lost frame or corrupted frame and send back to the sender about the corrupted frame details. Then sender will resend the corrupted frame only. Then the data is going to be again reached to the receiver successfully. So this process we can call it as a automatic repeat request, ARQ. Okay, that means, so this corrupted frame identification and resend the corrupted frame from sender to receiver. So this process we can call it as ARQ, automatic repeat request. It's a very important, please remember. Phases in error control. Okay, the error control mechanism in data link layer involves the following phases. One is detection of error, acknowledgement. There are two things. In the detection of error, transmission error, if any is detected by either the sender or the receiver. Okay, just identify the error where exactly. Okay, it has to be detected by either sender or receiver. Anybody can able to identify this transmission errors. And acknowledgement may be positive or negative. What is positive, what is negative? Positive acknowledgement is nothing but so successfully data is received. Okay, source from source and receiver. Okay, sender is going to send the data, receiver successfully received the data without any data loss, then the receiver send an acknowledgement, that is positive acknowledgement. If the receiver received any data with some data frames are lost, okay, that means negative acknowledgement. When negative acknowledgement received by the sender, it means that so the complete data is not received by the receiver. Clear? The same thing, positive acknowledgement, negative acknowledgement. On receiver receiving a correct frame, the receiver sends a positive acknowledgement. If the receiver receive a damaged frame or duplicate frames or corrupted frames, then the receiver sends a negative acknowledgement back to the sender. Okay, what is retransmission? Retransmission means so whenever the sender maintain a clock and sets a timeout period, that means so I already told now for each and every data frame has a some lifetime. So within the lifetime, that means for example 10 seconds, we can assume that within 10 seconds the data frame has to transfer across the network from source system to destination system. If it exceeds the 10 seconds, then the data frame is going to be lost. Okay, then that particular data frame has to retransmit from sender to receiver. Okay, if acknowledgement of data frame previously transmitted does not arrive before the timeout, right, before the timeout, if the acknowledgement received, then the sender again retransmit the particular frame. Or even negative acknowledgement also when received by the sender, okay, from the receiver, then sender will retransmit the particular frame. Clear? Error control techniques in data link layer. So there is a stop and wait ARQ, go back and ARQ, selective repeat ARQ. There are three types error control techniques. Okay, stop and wait, go back and selective repeat. Okay, we will discuss each and every error control techniques. In stop and wait ARQ, okay, in stop and wait ARQ, a timeout counter is maintained by the sender. That means so there is a sender and receiver. So here there is a the sender will maintain a timeout. Okay, the sender will maintain a timer. So when exactly the sender sends a data frame. Okay, so within the for example it will take 10 seconds, okay, to reach to the receiver. Okay, after reaching to the receiver, again what the receiver will do, immediately receiver will send an acknowledgement, whatever either positive or negative, some acknowledgement is going to be sent. So this is 10 seconds and acknowledgement again will reach in 10 seconds, 20 seconds. Within the 20 seconds after sending the data frame, the sender has to receive the acknowledgement. If not receive any acknowledgement, what will happen? Again sender again retransmit the same data frame again. Why? Because the sender think that okay, the data is not received by the receiver, maybe data lost. Okay, that is the reason again sender will retransmit. Okay, so that is why stop and wait. First he will send the data frame 1 until getting an acknowledgement from the receiver. The sender won't send second data frame. Okay, His sender will wait for the acknowledgement for first data frame. After receiving the first acknowledgement of first data frame, then only sender will send the second frame, right? That's why stop and wait, right? If the sender receive acknowledgement of the send frame within the time, the sender is confirmed about successful delivery of the frame. It then transmit the next frame in queue. If the sender does not receive the acknowledgement within the time, what will happen? The sender assume that either the frame or acknowledgement is lost in the transit. Okay, maybe data frame may be reached, but acknowledgement not received. Otherwise, data frame itself not received by the receiver. There are two cases again. So that, and then again retransmit the frame once again. Even acknowledgement not received also, the sender will again resend the same frame. If the sender receives a negative acknowledgement, the sender retransmit the frame, right? That means, so the receiver received the data, but the data, whatever the data frame received, that may be corrected. Okay, that's why receiver will send negative acknowledgement. Next, go back and ARQ. Okay, in this go back and ARQ, the sender has a buffer called sending window. Please remember, the sender has a buffer called sending window. Okay, the sender sends multiple frames based upon sending window size without receiving the acknowledgement of the previous one, right? Here what will happen? The sender will send the multiple frames based upon the sending window size. That means, for example, in this sending window size size is 10 frames, right? So first of all, instead of sending one frame and waiting for another frame, here what will happen? First, the sender will send from source to destination. Sender will send 10 frames continuously, and there is no waiting for acknowledgement for first or second frame. So straight away 10 frames are going to be transmitted. Okay, because those are the size of the in our example, the sending window size is 10 frames. So the 10 frames are going to be transmitted. So without receiving the acknowledgement of the previous one, right? The receiver receives frames one by one. That is maybe 1, 2 or 4, 3 again. So irrespective of any order. So finally the receiver will receive all the frames. So it keep track of incoming frame sequence number and sends a corresponding acknowledgement frame. So once the receiver will receive the frames of 10 frames irrespective of any sequence number. Okay, and again what the receiver will do, it just arrange all the sequence numbers and just check out whether all the frames are received or not. Okay, after receiving, the receiver will send, okay, first frame received, send an acknowledgement for okay, successful, that is a positive acknowledgement is going to be transmitted to the sender. Next, second frame, third frame, fourth frame, like this the acknowledgements are going to be transmitted from the receiver to sender. If the sender has received positive acknowledgement for all the frames, it sends the next set of frames. So now the sending window size is 1 to 10 now. So now 1 to 10 received all our positive acknowledgements, then 11 to 20 frames are again transmitted. If sender received negative acknowledgement or has not received the acknowledgement for particular frame, assume that from 1 to 10, so 7th frame acknowledgement is not received by the sender. Okay, then the sender think that, okay, it may be acknowledgement lost or data frame lost. So that is the reason again it retransmit all the frames, after which it does not receive any positive acknowledgement. That means, so 1 to 6 are, they think that it is successfully received. When 7 is not received means, so from 7 to 10, these frames again retransmitted to the receiver, right? So this is the concept of go back and ARQ. Clear? Next is selective repeat. Selective repeat ARQ. So here both the sender and receiver have buffer called sending window and receiving window respectively. Okay. So earlier what will happen? Only sender window is there, sending window. Assume that in our example 10 frames is the sending window size. Now here we have now both sides, in the sender side as well as receiver side having the sending window size. Okay. Both having the 10 frames and 10 frames like this. Okay. Now the receiver keep track of incoming frame sequence numbers, buffer the frames in memory, right? So however sender will just store into the sending window. After receiving, the receiver also will store the sequence number in the memory. Okay. And it sends acknowledgement for all successful received frames and sends negative acknowledgement for only the frames which are missing or damaged, isn't it? That will happen. Right? The sender in this case sends only frame for which negative acknowledgement is received. Okay, the sender in this case sends only frame which is negative acknowledgement is received. Okay, so if any negative acknowledgement received, then what will happen? Only those frames are going to be resent. Okay, so this flow control is completed. In data link layer, the sender continue to send the frames only after it has received acknowledgements from the user to the previous frame. This called feedback based flow control. Okay, so feedback based flow control means, so the sender continuously send the frames only after it has received acknowledgements from the user and for the previous frame. Okay, only the previous frame acknowledgements are going to be received, and this, based on this, we are going to be retransmit the next frames. So that is why we can call it as feedback based. So last frame is received, now we are going to send the next frame. So they are taking the feedback now, so successfully received or not. So that is the reason we are naming like a feedback based flow control, and this can be two types. So that is a stop and wait and sliding window protocol. Okay, so we will discuss this stop and wait and sliding window protocol. Stop and wait protocol. Okay, and this stop and wait protocol, the sender sends a frame and waits for acknowledgement. So that means, so here, so how we are discussed, so sender as well as receiver here. Okay, now sender will first send a one data packet or data frame. Okay, and sender now wait for the acknowledgement from receiver. So once getting an acknowledgement from receiver, whether it is positive acknowledgement or negative acknowledgement, that is secondary. First, whenever receive the acknowledgement from the receiver, okay, then sender will send next frame. Okay, so if it is a negative acknowledgement, the same frame is again the sender will resend the to the receiver, right? So assume that this is F1, this is F2. If the sender received a positive acknowledgement, okay, then sender will send second frame like this. Once the receiver receives the frame, it sends an acknowledgement frame back to the sender, right? So without receiving the any frame, so sender receiver could not able to send any acknowledgement, right? On receiving the acknowledgement frame, the sender understands that the receiver is ready to accept the next frame, isn't it? So the sender also knows that now the receiver is ready to take the next frame whenever once the acknowledgement is received from the receiver, right? Next is the sliding window. Okay, and this is very important, please remember. Okay, this sliding window protocol improves the efficiency of stop and wait protocol by allowing multiple frames to be transmitted before receiving an acknowledgement. Clear? So what happened here? So this sliding window is a one protocol. This is also ISO standardized protocol which improves the efficiency of stop and wait protocol. So just now we have discussed what is stop and wait protocol, isn't it? It just try to improve the efficiency of stop and wait protocol by how it is going to improve the efficiency of stop and wait by allowing multiple frames to be transmitted before receiving an acknowledgement. Isn't it? So in stop and wait protocol, what we have discussed so far. So first of all, sender will send a frame, then receiver will send an acknowledgement for the received frame. Again, sender is waiting for that acknowledgement, isn't it? Once after receiving the acknowledgement only, sender is going to send another frame, isn't it? But whereas in the sliding window protocol, what will happen? The sender need not wait for an acknowledgement from the receiver. So sender will send multiple frames without by not waiting for an acknowledgement. Okay, both sender and receiver has finalized sized buffers called window. Okay, and here there is a finite sized. Okay, both sender and receiver has a finite size. That means, for example, sender as well as receiver here, right? If sender buffer size here, that means sender can able to store 10 frames. Assume that sender can able to store 10 frames. At the same time, receiver also can able to store 10 frames in a buffer. Okay, now here sender to receiver, instead of sending one frame, so sender will send 10 frames. Why? Because 10 means that is depend upon the sender as well as receiver buffer size. Okay, so based on this, the 10 frames are going to transmit it to receiver, and receiver capacity also having a same finite size. Okay, this receiver is also having 10 frames buffer size, then the receiver will also store the 10 frames at a time, and then again send the acknowledgement for 10 frames, right? After receiving an acknowledgement, again sender will send next to 10 frames. So like this, transmission is going to be taken place. The sender and receiver agrees upon the number of frames to be sent based upon the buffer size, isn't it? That means before starting the transmission itself, the sender and receiver will understand on one particular finite size. Okay, that means always we couldn't expect the same size will be having both the sender and receiver side. So sometimes what will happen, sender have a more size and receiver may be less, and some other time sender having a less buffer size and receiver may have more. Then at that time both can finalize with one particular available size of both sides. Okay, assume that sender having a 100 is a buffer size and receiver having a 80 buffer size. Okay, now what they are going to do, and both they are going to finalize with 50 or 60 or something. Okay, so based on this, the buffer size is going to be there. So based on this, the sender is going to transmit this much of a number of frames at a time, and receiver will able to receive those frames and send the acknowledgement for received frames. Clear? The sender sends multiple frames in a sequence without waiting for acknowledgement. Clear? And when it's a sending window is failed, it waits for an acknowledgement, right? So what happened when sending window is failed? That means the buffer, isn't it? But the size buffer, what we have in the example, what we have taken. So 10 is then. So that window is sending window is failed. So it waits for acknowledgement, isn't it? So that's why. So if it is failed, it waits for acknowledgement. That means it feels that it's already sent and it's waiting for an acknowledgement. Until getting an acknowledgement, again it won't send anything, right? So that will happen. That is only a small drawback that we have to need to check for every time. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.